Hi everyone, again we are continuing the LPS class, and today we are continuing with the TK um, session. So in the last lecture we saw some of the additional commands of TK. Mainly we talked about the canvas, how to create the canvas, what are the item attributes, what are the bindings, what are the tags, and all those things. Today we are going to look at one example of using a canvas, and this is one application that we are going to build, and then I'm going to walk you through that application and see whether we can make use of some of these concepts that we learned in our class. So again, the canvas widget is it manages a 2D collection of graphical objects. Lines, circles, images. We actually went and put some smiley face with a circle and then two small circles with um, black color in it, and then we also drew some arcs to represent the mouth, and so we actually now have a fairly good understanding as to how to draw this. So I'm going to go through this particular example. So the application that we will be building is this furniture arranger application. It is a simple app to help you to decide how to arrange the furniture, and we also use some drawing primitives to represent pieces of furniture. So here there's an oval, some squares, and rectangles. So these represent the furniture, maybe the top-down view, you can say. And then we will use multiple tags per item, and then we will implement the behaviors based on these tags. So let's see how we can do it. So we define some procedures. So here we are going to define the procedures upfront. So here procedure called setup canvas. This is essentially we first erase everything, all the Windows attributes, and then basically we will build the canvas. So this is the create canvas command where we create the canvas, and the widget is .c, and then we say the pack command, and then we create those chairs. So those are the small squares here. So we create them. So for each of these numbers, essentially we create a small rectangle, and essentially that is with the actual location, basically that is what these represent. So and then we fill the thing with the red, and then we will tags as chair and furniture. So as in the furniture big picture, this indicates the chair, and then now we will set up the chair behavior. For that we use the bind command, and then the bind command is essentially we say that basically we capture the event enter, and then we say basically it's current. So basically we take the chair to the current location and then fill it with blue, and then if the leave command is given, then we basically we move it and then we fill it with red so that it can be moved. Now the second one is we create the table. That's those the oval shaped figure here basically. So so for creating the table, again we create the oval, and now we'll fill it with pink, and then we create some tags for it, which is table, rotatable, and furniture. And then again we say similar kind of binding that we create, which is the table behavior is basically based on the events. So it turns into sky blue and then back to pink. And then the couch is actually represented as the rectangle in this picture. This is this one. So these are chair, this is a table, and this is a couch. So the couch is actually filled with orange, and then we have a couch also is rotatable, and then it's furniture. And then we have same way we define the bindings, and then here the binding is basically like it's fill it with green instead of orange. Now we need to also since we are generating tags which are rotatable, so we need to define the tags also. So here we notice that actually like now this is actually these are all like how this is. So here we denote all these bindings here. So the rotatable is essentially like we bind it to button 2, and then that causes it to rotate. So this is one of the mouse click buttons. And then we also need to set up the furniture behavior, because that is the highest hierarchy, highest level of hierarchy in this tags. Basically this is all furniture, this is furniture, and then we looked at chair is also furniture. So the way that we define the furniture behavior is the button 1, where we what is the current X and current Y. Okay, so and then we also generate the motion, which is like once you click on it and then you can grab it to move a particular furniture. That move is represented as basically we say that it's move from current to the, or basically like the current position is moved to whatever we captured the previous ones, the percentage X and percentage Y, from there to the current X and current Y. So we just add that, and then that is what your new position is, and then that is set as the new current X and current Y. So once we define this all these procedures, now we are ready to actually move, and then now we also want to do some rotate. So the procedure rotate is essentially like so we find what is the element that from that window, like what is the selection, and then we also like set the coordinates to that particular coordinates, and then we basically move it or essentially like find the new coordinates based on this formula, basically, which is we subtract the original one by 2. So now that becomes the new coordinate essentially by doing some more manipulation, and that's the rotate function. Basically what that means is like you can grab something and then rotate it whichever way that you want. So that's what this procedure will do. Now that we define all the procedures, we can now set up the canvas, basically using setup canvas, which is already defined as a procedure here, which is what creates that canvas. And then we bind the top level window to control L, and then that sets up the canvas. And then we basically put the title as the furniture arranger, which is right here. So it's a fairly simple program. I think you should be able to just go through it and understand this. So now let's look at some more topics. Essentially, one thing that I want to introduce to you is this Ticklets. Ticklets are just plugins for your browser. so that you can embed a TK program inside the browser in browser XML, and that actually now can work just like any other TK program. So there are some Netscape plugins which I don't know. I mean, so that you can look at, but mainly like I mean the programs run as ticklets inside the browser, and you need to remember a few things. One is the file system access is severely restricted, so you don't want to try to access some files where you don't have permissions for. And then EXCC, using EXCC is prohibited, so you don't want to use that. And the network access is also prohibited, so you cannot go and find things in the network. And grabbing display is also prohibited, because you don't want to grab display from during the execution of the program, so that it will never come back basically. And then the direct window manager interaction is also prohibited, so you don't want to interact directly with the window manager to gather anything. And then there are no menu widgets, so as long as you can keep track of this, you can write your own tickle or ticklets, which is embedded TK programs. And what can you do with ticklets? Basically, like you can design tools like calculator on the fly. You can do like graphical demonstrations and games, design games in the browser, in the net. So that's about ticklets. And mainly, like I mean, for using a ticklet, the user needs to have install the plugin. Ticklet file system access is limited to using source and load script directories. So those directories are open for you, so that you can source it or can load those scripts essentially. And then you have to use open as a read only in the script directory, so you can read from the script directory but not write to it. And then using the new command make temp to create read write temporary directory. So that's the bottom line basically, like I mean, so you can use only like these kind of things. And then you cannot get a file listing, and there is no standard or standard in. Some commands have extensions to help, like for example the image data can come from a MIME encoded string. So if you were to take the furniture mover and convert that into a ticklet, basically things that to do is one is first of all the furniture mover application itself makes a perfect ticklet. Anyone in the world could rearrange the furniture. There's only one change to the source, basically like this is the one, which is if info exists embed args equal to 0, then do the window manager. The embed args is an array containing the parameters from HTML. Can use them as a command line arguments for the ticklet. So let's create a HTML page for running this furniture mover. So here we call the title, and then the body is essentially like here we embed source the furniture.tickle, and then we specify the width and height, and then we specify what it does. Basically that's the import. Now we need to place the furniture.tickle and the furniture.html in the same directory in your area or in the web server, and then using the HTML file with even like any browser will show the ticklet essentially if the plugin is installed. So one thing that you can do is you can include the link to the tickle plugin page, plugin home page, and a brief explanation of each of the ticklet enhanced pages. So that's pretty much on the ticklet. Now we will go into the next topic, which is essentially how to extend Tcl. So the basic philosophy behind that is we focus on the primitives. Some of the basics we already talked about, the interpreters and executing scripts. The implementing new commands is another one, and then the managing packages. How do you do the dynamic loading, and managing result string, which is how do you pass the results, and then some of the usual library procedures like parsing variables, list, and hash tables. So in general, the philosophy basically it's better to write Tcl scripts than C code, mainly because it's faster development. Also, it is higher level and no compilation, so it's more flexible. This section is what we saw when we introduced Tcl in the very early stages. Why write in C? So if we need to access the hardware facilities or any kind of facilities provided by the operating system, then we need to use C. And then if the program itself is big and basically there's a lot more efficiency to be gained, then it's better to use C. And the other thing is when the code becomes complex, the structure becomes much more important. So the way that definitely, like, I mean, we need to have some structure, how to write various subroutines, things like that. Again, in that case, C will be a better language. So the implementing the new Tcl commands that provide a few orthogonal primitives. There are some Tcl commands that can actually give some extra ones. So the low level to provide independent access to all the key features with this primitives, and then it's also high level of high enough level to hide the unimportant details, and that allows an efficient implementation. So here we are comparing like 3 different Tcls for weather reports. So the goal is to retrieve the weather reports over a network from various servers. So the first Tcl command is to use the retrieve report format and print on the standard output. This is too high level and so it is inflexible. Now we can write another command which opens a socket to the weather server, select a station and retrieve the first line of the report. This is too low level. So again, like, I mean, we may not use this kind of information even though this is provided in Tcl. Finally, the command set 3, basically the algorithm that is followed is to return the list of all the available stations, given station name, retrieve report. So this kind of thing is just right. So how do we design new commands essentially? So couple of useful tips, basically choose textual names for objects. So dialog.bottom.ok or file tree or standard in, and then use the hash tables to map to C structures essentially. Object oriented commands, essentially they are basically dialog.bottom.ok, and then we use configure and then we say foreground is red. So these kind of object oriented commands are good for small number of well defined objects and doesn't pollute the namespace and allows similar commands for different objects. And then we also have action oriented commands like string compare x and y. This one is useful if many objects are short-lived for many objects or short-lived objects. These commands are useful. Now, how do we format the command results? Couple of suggestions, essentially, like make them easy to parse with Tcl scripts. So here, like temp 53 high, 68 low, 37 preset, 0.02 sky part. So here it's very hard if you are using these numbers. So we got to convert them over to symbolic wherever possible. So we don't use 53, 68, 37.02 and 7. Instead we need to replace it by like high temp, low temp, things like that. And then we can also use the package prefixes in command names and global variables to distinguish where exactly it is coming from. For example, WTHR stations denote the packaging information for this particular command, and weather report is another command, and VD play is another one. So these kind of naming convention can also allow packages to coexist without any name clashes. So now let's talk about the interpreters. Again, the Tcl interp structure encapsulates the execution state, captures the variables, the commands implemented in C, the Tcl procedures, and then the execution stack. We can have many interpreters in a single application, but just only one is active sometimes. And creating and deleting interpreters, basically in Tcl we can do like a star interrupt, which creates an interpreter with the Tcl interp command, and then we can assign the interp to the Tcl create interp. This is another way to create one, and then where we can also delete it by just doing a Tcl delete interp command. So now, how do we execute Tcl scripts essentially? So here we have this variable declared, and then we can use Tcl eval interp with set a equal to 1. This is one way to execute the Tcl script. The other one is essentially like we can put it into a file called init.tcl, and then we can just say Tcl eval file interp and then that file name. And then finally we can also specify in a different way, which is using the bar eval command. And then here we give like the interp set a and 1 as 4 different objects. The code itself contains whether there is a success or failure, and it comes to like Tcl OK if it is a normal completion, and then generates Tcl error if any error occurred during the execution. We can also point to the result through the interp arrow to result, and that points to the string that is has whether it is a Tcl OK or Tcl error. And usually what we want is application should display the result or message for the user. Now just to another thing is where do these scripts coming from? read from the standard input. I think you can answer all these questions like how do we read from the standard input, read from the script file, associate X events, wait for events, invoke associated scripts, and then embed it in C code. So here is one way to create new commands. So we call this EQ command as an integer, and here we specify like client data, tickle interpreter, and some argc and character argv. So if the argc is not equal to 3, then basically we just throw the result as wrong number of arguments and then return the tickle error. Now the next one that we will see is we do a string comparison between the data 1 and data 2, and if they are equal, then we say basically that the commands are equivalent. Otherwise, we will say like command is not equal, and then we just return the tickle OK value. So now to register with interpreter, we need to do the tickle create command, interpreter, EQ command, client data, and null. So once we register, then the EQ command will be called whenever any EQ is invoked in the interpreter. So we just kind of a binding EQ to EQ command, so that if you just type EQ, the interpreter knows that it needs to call the command. And we can also delete the command through this another function, which is tickle delete command. So the tickle create command creates the shortcut, and then tickle delete command will delete that. So here is the client data essentially. So the create command, we create that client data, and then we say like EQ command client data, client data. So usually we pass only one word value to the command procedures and their callbacks, but the client data here is usually a pointer to a data structure manipulated by the procedure. So we can pass the pointers in and out of the client data type basically. For example, like tickle create demo client data and then gizmo pointer. The gizmo pointer we can define gizmo star and then client data. So essentially it lets many object commands share one command block. So what are the conventions for defining packages in Pickle? So one is the goal is to make it easy to improve and use tickle extensions. So we can use the package prefixes to prevent the name conflicts. So we basically like kind of pick a short prefix for a package. For example, the RDB is read, and then we use in all global names essentially. So C procedure will have RDB open, C variable will have RDB number cuts, things like that, and then tickle will have RDB query. So this way, like if you follow this definite prefixes, then we can be successful in using the TK. So here is another example of creating the package initialization procedure. Name of the package is rdb init. The create packages commands and it creates the packages commands and evaluates the startup script if there is any. So how does it do it? So rdb init tickle interpreter, and then we execute tickle commands one by one, and then finally we return the tickle eval file. To use the package, essentially, like we just use the command basically compile as a shared library. Example on Solaris, basically we just say cc -k pick -c rdb.c and then the whole thing. We can also dynamically load tickle programs, but mostly into tickle sh or wish. These are the two shells that can load the programs, and then tickle will call the rdb init to initialize the package. The command for dynamically loading the thing is basically load rdb.so and then leave it as rdb. Now the load command that can have several forms: load file name package name, load maybe it's file name and package name. Whereas the file name is it's tagged as like .xyz.so, so it is the compiled form of library or library, and then the package name is xyz, which and we can use the info shared lib extension to decide between DLL or .so, etc. We can also use info loaded command to see what packages have been loaded and they are active. We can also load packages statically, that is tickle static package, tickle interpreter, character, what is the character, and then proc. We basically the package init proc we just initialize here, and then we just say load with an empty string xyz. So managing the result string. So we need conventions for the interpreter result, or basically how the result is getting. So one thing is it permits results of any length. So and then we have to avoid malloc overheads if possible, and then avoid storage reclamation problems, and then keep it as simple as possible. So the last one is earlier like the easier said than done, but that's what we need to strive. And then finally and then the normal state of the interpreter is to invoke this the interpreter essentially. So here basically like the result has some number here and then it's called preproc. Okay. Sandeep, can you pause the audio? So as I mentioned, we can register with the interpreter, and then we can use the command without pointing to any other place. And then for the client data, essentially, like, so we created this, and then we can actually cast pointers in and out of client data type by using these kind of commands. Actually, like the create command, where you're inside that and with a gizmo pointer, and then we define the gizmo pointer as outside with the gizmo as its class, and then it's also belongs to the client data. So the client data is usually a pointer to the data structure manipulated by the procedure. So that's why we can do all these kind of things. And then the many object oriented or the object commands share one command prop. So we talked about this. We talked about these things, and then here we talked about this dynamic loading. So the load command. Load command is essentially like, I mean, you can have many forms. One is load just file name. We can also specify file name and then the package name, or load everything in the package name, which is, we denote this quotes here. File name is any kind of SO signal, SO file dot SO. Package name is just XYZ inside that. You can also use info shared live extension for to decide between DLL, SO, etc. You can also use info loaded to see which packages are loaded in the system. And also we can load the packages statically. That is Tcl static package, Tcl interpreter, the characters in the package name, and then Tcl package init proc, basically set to the init proc, and it's also using the safe init proc. And if these conditions are met, then something will take XYZ, which is one other thing. And then the dynamic loading is always preferring with many tools and many areas. We saw this essentially, like, I mean, so we need conventions for the interpreter followed by interpreter arrow result. Here we want to avoid malloc overhead. So malloc is a C function to allocate memory, and you don't want to use that if possible. And then we can avoid the storage reclamation problems, that is the leaks essentially. And then we want to keep the name as simple as possible. So here one quick example. This is the normal state of the interpreter. That is, the command procedure is not invoked. What is the interpreter state? So it writes out the results and then it's frees the processes. So by default, the command returns just an empty string. So a static, semi-static result is option 1, where we can write out saying that the result is 0, and that's about it. Option 2 is the pre-allocated space in the interpreter, and then we can write it into that. So sprintf of printf interrupt the interpreter result is value is %d and then I. So that results in this kind of UI where we have the result as a pointer here, and then free proc, there's a value for that. we went through all these things now. So here, and then the third option is to allow a new space for the result, which is the interpreter result equal to malloc 2000, then interrupt fresh proc is free or free proc is free, and then the interpreter can put that as a thing which is occupying zero space. Tcl will call this free proc if not null to dispose of the result. So the result is created and then it is sent to the program for further processing while this program itself disappears. So the mechanism supports storage allocators other than malloc and free. So how do we manage results? Essentially, like we can use the library procedures. Tcl result set result is interpreted in string and then replaces the old value. Tcl append result interpreter string 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 and then character star and null. This extends the old value. Tcl append element and then interpreter and string extends the old value as a list. And then finally there is a reset result which will just clear the old value. So the utility parsing is essentially like command procedures to parse arguments. So here in integer this is one type of thing where code equal to tcl getInt interrupt sorry interpreter argv1 and value, and it stores integer values, returns tcl tk or tcl error, and then if there is a parse error then you can get like refund or so in with our company. And then for parsing there are other procedures. Tcl get double, these are like double in the context of floating point numbers. Tcl expression double, get boolean double, expr boolean, and then expr long and expr string. Tcl get boolean accepts s, false, 1 or a 0. expr is basically like variations of interpreter argument as an expression. So some more things on the variables: read, write, and unset. So how do we do it? Is basically like we set the value, and then value equal to tcl get var interpreter a, whatever the value from that you get it, and then we just set the var to a to the interpreter, and then we unset var any of the other variables already there. And then we can set traces basically like that is going from various things essentially. So interpreter quotes a tcl trace reads that enables the tcl trace reads, and then tcl trace writes, basically those two, and then trace proc and the command the client data. So the trace proc will be called during each read or write of a monitor, and then it can write any override any value read or rewritten. In the parsing assembling proper lists are like this basically. So there is one split list and then merge, but the more importantly like the dynamics is another one. We think there are you see like the split list essentially like splits all these lists into multiple objects, whereas tcl merge command actually merges list files into a single data structure. And then some flexible hash tables are initialize hash table, which is tickle init hash table, create hash entry, find hash entry, delete hash entry, and delete hash table. So these kind of procedures are like having associative arrays in C. Excellent way to store the client data records for object-oriented command. Now comes to dynamic strings. Essentially, these are strings that can be handled dynamically. So dstring init. You also have dstring append, dstring append element, dstring value, and then dstring free. So dynamic strings actually grow efficiently without bounds. This is like a good string class in C++ and used internally by Tcl for result management, etc. I think I'm going to stop at this point. We will continue extending the Tcl. Actually, like I'll just summarize this one section and then we'll see the next section in the next class. So finally, on the summary, essentially like interfaces to C are fairly simple. Tcl was designed to make this true, so it has to be simple. And then we want to focus on primitives. Use the Tcl scripts to compose fancy features. So today we saw like couple of big topics. One is we finished the canvas widget using and when demonstrated using a furniture mover program. And then on the second part, we actually went through how to interface with C language. So how to extend Tcl into C. So I think that's pretty much it. We will cover some more items in the next one, and hopefully I will wrap up next session, or we may need one more session to wrap up. Okay. Thank you very much. Bye bye.